Types of equations we're going to be working with in this section. The first is solving rational or fractional equations. Our steps go as follows. Factor denominators if necessary. We may not always have to do this, but if we can, we need to. Next, check for restrictions on the variable. In fact, this one is very important. Check for restrictions on the variable by setting each denominator equal to 0. Next, find the least common denominator of the denominators. Multiply each piece of the equation by that least common denominator to clear the fractions. Solve our resulting equation and then check your answer. Make sure that it doesn't match with one of the values that were restricted back in step 2. If all found solutions are invalid, then there are no solutions. A couple things to keep in mind. First is that if you get an equation that is linear, we have an x to the first, it's the highest exponent, then we can solve as we've done linear equations and we will have one possible solution to check. If the resulting equation is quadratic, highest exponent is x squared, then solve by setting the equation equal to 0 and factoring. And there we will have two possible solutions, and we want to check any of those. Our first example, solve the following rational equation. 1 over x plus 4 plus 1 over x minus 4 equals 22 over x squared minus 16. The first thing we need to do is factor the denominator, actually the far right denominator. This is going to factor as x plus 4, x minus 4. So we'll keep all the rest of that. It's 4 plus 1 over x minus 4. Next, we want to check for restrictions in the denominator. And looking at each of these, it appears that x cannot equal negative 4 because of this x plus 4 term, and x cannot equal positive 4 because of that denominator. And then the last denominator has those two same expressions in them. Next, we want to find our least common denominator. The least common denominator for these is going to be x plus 4 times x minus 4. The x plus 4 will cancel here. The x minus 4 will cancel here, and both will actually cancel in that term. Next, we want to multiply everything by x plus 4, x minus 4, x plus 4, x minus 4, and then on the right-hand side, x plus 4, x minus 4. That will result in an equation where the x plus 4 cancels out. We have 1 times x minus 4 plus 1 times x plus 4. Because again, these two terms or factors cancel. These two cancel as well. Equals 22. Because everything cancels there. All right, now this is a linear equation, so we can solve this. We'll have one possible solution. Distributing the 1 or dropping the parentheses, either will work. Plus x plus 4 equals 22. This is 2x equals 22. And dividing by 2, we see that x equals 11. Now because we have these restrictions up here, x cannot equal negative 4 or positive 4, because 11 is neither of those, this should be a valid solution, and we could evaluate this. We could plug it into that equation and see if it works. Let's see, that'd be 1/15 plus 1/7. Again, I'm plugging these in. 1 over x plus 4, so that's 1/15. Plus 7 minus 4b, or 11 minus 4b, 7, so 1/7. Okay, and the other side, 22 divided by 11 squared minus 16. Those two values are the same. This checks out. All right, for our next example, we don't need to factor anything. So we can move on to variable restrictions. What would cause the denominator to be 0? And we should have x is not equal to negative 1. Now we can move on to our least common denominator. Now the only denominator we have is x plus 1. We have two of those, but we'll multiply by x plus 1 on both sides. Every term. which results in, well, those canceling. X plus 1 cancels here as well, so we will get 8 equals 3 times x plus 1 minus 13. Now we can solve this as a linear equation. Distributing, that would be 3x plus 3 minus 13 equals 8. Combining terms, we get negative 10 there, so 3x minus 10 equals 8. Can add 10 to both sides to see that 18 equals 3x, and then last dividing by 3, so x equals 6. Now the only restriction we had was that x is not equal to negative 1, so we're good in that regard. Now 8 divided by 6 plus 1, all right, and that is 3 minus 13 divided by 6 plus 1. Oh, 13. I put in a 1 instead of a 13. There we go. Okay, both sides of the equation are equal, and that is our valid solution. For our next example, we have a term we need to factor. We need to factor y squared minus 36, that quadratic down there. Let's see, so that would factor as y plus 6 and y minus 6. So I'm just going to scratch that term out and act like that was my original denominator. Now, our denominator would be 0 if y equals positive 6 or negative 6. Because of the y minus 6, the opposite of that is plus 6. So we have positive 6 and then negative 6 for the y plus 6. Now our least common denominator appears to be y minus 6 and y plus 6. So we'll multiply every term by that. Okay, same here, y plus 6, y minus 6. You want to be careful that we don't mix anything up. All right, so multiplying by y plus 6, y minus 6. It appears that the y minus 6 will cancel in the first, y plus 6 in the second, and in the third, the entire expression. So we're left with 2y times y plus 6, okay, minus 12 times y minus 6 equals 144, with that denominator out of the way. Now, distributing, we get 2y squared plus 12y minus 12y plus 6 times 12 is 72. 144. Now we can rearrange, we can combine like terms. Combine like terms to get 2y squared plus 72 equals 144. Now we want to isolate the y squared in this equation. Subtracting 72, we'll get 72 equals 2y squared. Dividing by 2, we see that y squared equals 36. Now, taking the square root of that, we come up with two possible solutions. Y equals plus or minus 6. And we don't need to check either of those because our restrictions here were that y could not be 6 or negative 6, which means we have no solution. There's our empty set solution. All right, for our last example, we again need to factor. Let's factor this expression on the right, and that would be x minus 3, x plus 2. Yes, that works. All right, so I'm going to cut that out. Now I'm going to multiply both sides. I'm just getting ahead of myself. My denominator would be 0 if x were 3 or negative 2. So x cannot be 3 or negative 2. And then from there, it looks like our least common denominator will include both of those factors, x minus 3 and x plus 2. All right, now I'm going to jump to actually writing that in. That's going to be 3 times, I would multiply by x minus 3, x plus 2, divided by x minus 3. That is the first term when I multiply that least common denominator in there. Minus 4 times x minus 3, x plus 2 over x plus 2 equals 10 times x minus 3, x plus 2 divided by x minus 3, x plus 2. Now simplifying, we have those terms cancel, those two cancel, and all of these cancel. Now I'm going to go ahead and distribute, because if I take that out, I'm going to have 3 times x plus 2. That would be 3x plus 6. And this, with the x plus 2's out, I'll distribute the negative 4 to be negative 4x plus 12 equals 10. All right, combining like terms, I have a negative x and a, that's the other side, those two, that'd be plus 18 equals 10. So now I will subtract 18 to get negative x equals negative 8, which means that x equals positive 8. Okay, now that is not restricted, so I'm going to go ahead and check this. So 3 divided by quantity 8 minus 3 minus 4 divided by quantity 8 plus 2. Okay, 0.2 is what the left side is. Now 10 divided by 8 minus 3 times 8 plus 2. And that is also 0.2, so this value checks out.